Hello everyone. In today's video we will be reviewing how to multiply and divide with decimal numbers, but we are going to focus on some very specific things. In this part we are going to focus on how to do these quickly and without going into long division or vertical multiplication if we can avoid it. Whereas here, where it's kind of unavoidable, we are actually going to do long division with decimal numbers. So let's get started immediately. I'm going to be reminding you some basic rules as we go along, but generally speaking, this is something that we have done many times before in the past. So try to follow along. Also, if you have a notebook, actually you should have a notebook to write these down. Get your notebook, try to solve these on your own, and then come back to see if you did them correctly. Pause the video to do so. All right, so here we have 0.7 times 20. I think of 7 times 2, which makes 14, right? But one of the numbers I'm multiplying has one digit to the right of a decimal point, right? And so normally I should have one number to the right of a decimal point here in my result, but because the other number I'm multiplying with has a 0, that means that it's just going to stay 14. You can basically think of it like this: since in multiplication, right? In multiplication, however many zeros there are on this number, so 20, 800, 3000, right? It pushes the decimal point of the other number to the right. So here, 1 0 pushed the decimal point to the left by one spot. This became 7, let's say, and 7 times 2 makes 14. Here, 6 times 8 makes 48 normally. 1 0 cancels out the one number to the right of the decimal point, and then the other 0 gets added to the result, so 480. Next, we have 0.4 times 3000. 4 times 3 makes 12. One of the zeros cancels out the one number to the right of the decimal point, and the other two get added to the result. Then we have 0.06 times 60. 6 times 6 makes 36. But this has two numbers to the right of the decimal point, whereas this only has one 0. So there still needs to be one number to the right of the decimal point in my result. So 3.6 is the result now. 0.09 times 900. Well, 9 times 9 makes 81. And the two zeros cancel out the two numbers to the right of the decimal point here, so 81 actually is my result. Next up we have 0.07 times 7,000. It's actually, yeah. 7 times 7 makes 49. Two of the three zeros cancel out the two numbers to the right of the decimal point here, and the other 0 gets added to the result. Here we have 0.005 times 50. Now, the 5 times 5 makes 25, right? 1 0 is used to cancel out one of the three numbers that are to the right of the decimal point, but then there's another 2. So there need to be two numbers to the right of the decimal point in my result. So my result needs to be 0.25. Next up, we have 0.003 times 400. 3 times 4 makes 12. And we have three numbers to the right of the decimal point here and two zeros. So two of these zeros cancel out two of these numbers, so but one is left. So there needs to be one number to the right of the decimal point in my result. Then we have 0.009 times 2,000. 2 times 9 makes 18, and the 3 zeros cancel out the 3 numbers to the right of the decimal point. Next up, we have 0.5 times 2. 5 times 2 makes 10, and we have one number to the right of the decimal point and no zeros. So there needs to be one number to the right of the decimal point in my result, which means I get 1.0 or just 1. Next up, we have 0.2 times 5. 2 times 5 makes 10 again. And again, I have the same thing as before, where one number is to the right of the decimal point. There are no zeros here. So again, I'd have 1.0 or just 1. Then we have 0.25 times 4. 4 times 25 makes 100, which is something that you should remember. 4 25s make 100. Here we have two numbers to the right of the decimal point, and here we have no zeros, so there need to be two numbers to the right of my result. So 1.00, or again, just 1. These three last multiplications are quite important, and you should remember them. Well, through enough practice, you will learn them. But it is very helpful to remember that these multiplications all make 1. Next up, we have 2.5 times 4. Again, 4 times 25 makes 100. This time, there's only one number to the right of the decimal point. So now the decimal point is going to go here. I'm going to get 10.0 or just 10. Next up, we have 2.5 times 2. 25 times 2 makes 50. With one number to the right of the decimal point and no zeros, that means the decimal point should go here, but I can just write this as 5. And if this is too difficult at any point, you can do these vertically. So you could, if you wanted to. Right. Why do I have white? 2.5 times 2 can be solved like this as well, although I don't think this is necessary anymore. Then we have 3.5 times 2. 35 times 2 makes 70. And here we have one number to the right of the decimal point, so the decimal point should go here, and I get 7.0, or just 7. Next, we have 4.5 times 2. 45 times 2 gives me 90. But again, the same thing as before. The decimal point is going to go here, and we're going to get 9. All right, so that's the multiplications. Let's go for the divisions. In the divisions, you need to remember that the zeros on this side push the decimal point to the left instead of the right. Okay? So, here, 21 divided by 3 normally gives me 7, right? And I have two numbers to the right of the decimal point already, and this 0 here is going to make me have one more number to the right of the decimal point. That means I need to have 3 numbers to the right of the decimal point. So I'm going to need to put in a couple of zeros here and get 0.07. 0.007. Next, we have 4.5 divided by 50. 45 divided by 5 gets us 9. There's one number to the right of the decimal point here, and a 0 on this side, so there need to be two numbers to the right of the decimal point in my result, meaning I need to put a 0 here, and then the decimal point. So my result is going to be 0.09. Then we have 3.6 divided by 400. 36 divided by 4 normally gives us 9. But I have one number to the right of the decimal point here and two zeros over here. So I'm going to need to have a total of 3 numbers to the right of the decimal point here. So I'm going to put in another 2 zeros, decimal point after them, and then the 0. So my result here is 0.009. Here we have 49 divided by 70. Now normally 49 divided by 7 gives us 7. But here there are no numbers to the right of a decimal point here, but there's a 0 here, right? Which means that I need to have one number to the right of a decimal point in my result. So my result is going to be 0.7. Next up, we have 56 divided by 700. Normally, 56 divided by 7 makes 8. But now, because there are two zeros here, I'm going to need to have two numbers to the right of the decimal point here, meaning that I need to put in another 0, then the decimal point, and a 0 in front of it. So 0.08. Next, we have 24 divided by 8,000. Normally, 24 divided by 8 gives us 3, but because of these 3 zeros, I need to have 3 numbers to the right of my decimal point here. So a couple of zeros are needed, and then a 0 in front of the decimal point. Next up, we have 480 divided by 60. Normally, 48 divided by 6 gives us, well, 8. And now what happens is that this 0 cancels out with this 0, and what we're left with is actually 8. So just 8. It's like doing 48 divided by 6. Next up, we have 350 divided by 500. 35 divided by 5 normally gives us 7. And now this 0 gets canceled out with one of these zeros, but then there's another 0 here, meaning that there does need to be one number to the right of the decimal point in my result. Next, we have 810 divided by 9,000. Normally, 81 divided by 9 makes 9. And now we have 1 0 canceling out with one of these zeros. And then these two zeros here mean that I need to have two numbers to the right of my decimal point in the result. So my result is 0.09. Then we have 3,800. The two zeros on both sides cancel each other out. And it's like I'm doing 32 divided by 8, which makes 4. Again, these two zeros cancel out. These two zeros cancel out with these two zeros. So we're left with just 32 divided by 8. Next, we have 3,700 divided by 7,000. Normally, 35 divided by 7 makes 5. And now, with the zeros, these two cancel out with these two, but we have one more, which means we need to have a number to the right of the decimal point in the result, so we get 0.5. Next, we have 16 divided by 0.4. A reminder that when we have a decimal number to this side of the division, then it's the opposite, right? So you could flip this around. You could rewrite this as 16 times 10 divided by 4. The reason for that is that 0.4 is basically like saying 4/10. And if you remember how we divide with fractions, we flip the number around, right? But if you don't want to do it like that, what you could do instead is just say, okay, well, 16 divided by 4 makes 4. And this number, because there's one number to the right of the decimal point here, it's going to push the decimal point further to the right. Again, to the right. So this way in my result. But since there is no decimal point here, the invisible one, but if I push it to the right, I need to add a 0 here. So my result would be 40. And the same happens here. 32 divided by 0.08, it would say that 32 divided by 8 is just 4, right? And because there are two numbers to the right of the decimal point in the divisor, decimal point in my result gets pushed 2 places to the right, and I get 400. Here we have 0.24 divided by 0.006. So here I need to think 24 divided by 6 makes 4, right? 2 places to the right of the decimal point and my dividend are pulling the decimal point to the left. 3 places are pulling it to the right. So these two cancel out with 2 of these, and we're left with 1 place pulling to the right. So we get 40. Now, these divisions, let's erase all this, make some room. If you need to copy, go back in the video and pause. Let's make some room here. We have 112 divided by 350. These divisions need to be done vertically. You can't do them the way we just showed. The reason for that is you can't do 112 divided by 350 in your mind. When it comes to long division with decimal numbers, we have 3 categories, as we've explained in the past. And the 3 categories depend on where the decimal is. In this first category, you don't see any decimal numbers because we haven't written them yet. Decimal number is going to be the quotient. It's going to be the result. So, and the same goes for this. 3 divided by 600. The results are going to be the decimal numbers. So, here, normally I would start by asking, does 350 fit into 112? But the answer is immediately, no, it does not. So what needs to happen here is I need to put a 0 in the quotient, a decimal point, and then place a 0 at the end of my dividend. So this becomes 1,120. Now I can ask, how many times does 350 fit into this? I'm going to try 3. 3 times 350 is going to give us what? 1,050. Yeah. Then I do the subtraction. I get 70. Now the division is not over. I can put in another 0 and ask again, how many times does 350 fit into 700? You'll notice that after placing the decimal point, all the zeros come with no consequence. I can just add another 0 at the end of my remainder without any requirements, basically. With the first one, I need to place a decimal point, right? But after the first one, I don't need to do anything. I can just place more and more zeros. So now I ask, how many times does 350 fit into 700? The answer is 2. 2 times 350 is 700. (700 minus 700 is just 0. With no remainder left, now the division is over. And my result is 0.32. Here the same thing happens. I asked, does 600 fit into 3? No. So I put a 0 in the quotient, a decimal point, and I add a 0 here. So again I asked, does 600 fit into 30? No. So I put another 0 here and another 0 here. So I asked, does 600 fit into 300? Again, no. So I put another 0 here and another 0 here. And finally, yes, 600 does fit into 3,000. It fits 5 times. 5 times 600 means 3,000. Makes 3,000. And 3,000 minus 3,000 makes 0. And my result is 0.05. Next up, we have 37.8 divided by 18. So this is the second category where we have a decimal number in the divider, in the dividend. In this case, I begin by, I can start by doing 18 goes into 37 twice, right? 18 goes into 37 twice. 2 times 18 makes 36. 37 minus 36 makes 1. Now that you can see that I'm crossing this line where I go from the whole part of the number, the integral part of the number, into the decimal part, I'm crossing this decimal point. Right now, I need to put a decimal point in my result. And now I can pull down the 8. Comes 18, and I ask, how many times does 18 fit into 18? Well, once. 1 times 18 makes 18. 18 minus 18 makes 0. So my result is 2.1. In the second example, we have 8.88 divided by 2.4. Now we have a decimal point in both the dividend and the divisor. What needs to happen here is, before we begin, we need to remove this decimal point from the divisor. So to do that, what we do is Well, how would I remove this? I would remove it by moving it one place to the right. To do that, I need to multiply this number by 10. And this is something that can only be done before we start the division. So right now, that we haven't started yet. But to multiply this number with 10, I also need to multiply this number with 10. Kind of like in fractions, in equivalent fractions. So when I do 8.88 times 10, my result here is going to be 88.8. And here it's just going to be 24. And now we're back to this case where we have a decimal point in the dividend. We say, how many times does 24 fit into 88? I'm going to say 3. Let's try 3. 3 times 24, again, we're trying for 88. 3 times 24 makes 72. 88 minus 72 makes 16. And now that I'm going to pull down the next number and cross into the decimal part, I need to put a decimal point in my result, just like before. I pull down the 8, and I say how many times does 24 fit into 16? And the answer to that is 6. 6 times 24 makes exactly 168. And subtracting this is 0. So my result here is 3.6. Next up, here we have 9 divided by 0.4. Now we have a case that we just saw with the decimal point in the divisor. And we said that what we need to do in order to fix that is to multiply both sides by 10. Well, in this case then, if it was, for example, 0.456, I would need to multiply both sides by 100, because 3 digits to the right of the decimal point. But let's not make it overly complicated. So here we have 9 divided by 0.4. I multiply both sides by 10. This side becomes 4, and this side becomes 90. So we get 90 divided by 4. I ask, how many times does 4 fit into 9? The answer is 2. 2 times 4 makes 8. 9 minus 8 makes 1. Carry down the 0, comes 10. How many times does 4 fit into 10? The answer is 2. Again, 10 minus 8 is 2. And now that we have no other numbers to pull down, what I'm going to do is I'm going to put a decimal, like we did in the beginning. I put a decimal point in my result and a 0 on my remainder. It becomes 20. I say, how many times does 4 fit into 20? The answer is 5. All right. Here, now we could do this vertically. This could also be done the way I showed you before. So it could be done as long division, or it could be done as just a quick calculation in your mind. Either way would be fine. So to get rid of the decimal point here, I will have to multiply both sides by 100, because there are 2 numbers to the right of the decimal point here. So multiplying this by 100, this whole number will give us 5. And then multiplying this by 100 will give us 3,000. And then I say, how many times does 5 fit into 3? It doesn't. About 30 fits 6 times. 6 times 5 makes 30. 30 minus 30 makes 0. Pull down the 0. How many times does 5 fit into 0? 0. Carry down the 0. How many times does 5 fit into 0? 0. And since we have nothing else to pull down and our remainder is 0, that's our result of 600. And that will be all for today. See you again on Friday. Bye.